This meeting is being recorded.
Can you see my screen? No?
Yes, we can see your screen, but we still don't see your presentation slides. Just take your time.
Okay. Yeah.
Okay.
Huh? Can you see it now?
Yes, 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 we can see it.
Okay. Great. So, good morning, good afternoon, everyone. And at the outset, I would like to thank Dr. Evans, Dr. Hugo, Dr. Selvan for inviting me to. Actually, Dr. Selvan has been in contact with me for last 2-3 months and for finding a suitable time. And finally, we are here. So, indeed, I am privileged and delighted to be here to deliver the seminar. And the topic which I have chosen is the engineering education, envisioning future and preparing for it. So, of course, in the title, there are these three words. One is engineering education, another one is envisioning future, and then how to prepare for the future. So let us look at this one by one and see how the things are changing and what is going to happen, as we move. So if you ask, what is engineering? Engineering is the application of science for improving the quality of human life. And engineering is a profoundly creative process, because you have to design some devices, components, systems, which will improve the quality of human life. That is the objective of engineering. And of course, when we talk about engineering, there are constraints under which engineers have to work. And these constraints could be technical, they could be economic, they could be business, they could be political, they could be social, they could be even ethical. So under these constraints, the engineers have to perform and deliver something which will be useful to the human life. And technology, of course, is the outcome of the engineering as the time moves. So if I look at the engineering today, we find that there is an explosion of knowledge in every discipline of engineering. And I will look at historically very quickly, just to give a perspective of the engineering evolved. But today there is an explosion of knowledge in every discipline of engineering. And engineering has become more and more specialized. So today when we say that an electrical engineer, he knows very little about mechanical engineering or civil engineering or material science, and vice versa. I mean, this is the typical trend which you see. So engineering has got more and more compartmentalized over the years. And also, of late, we have seen that the biotechnology has become part of engineering. And there are many applications of biotechnology, right? And many approaches which people use in biotechnology are adapted to the engineering program. Engineering also has become more modeling and simulation based rather than real hands-on. So if you had asked the question about 100 years back, what the engineering would be, it essentially would mean something do by trial and error with your hands. Today, before you do something with your hands, you do a lot of simulation and modeling and make sure that the things really work. And then finally, you go and try to do it with your hands and create that object. And also of late, we have seen, at least in India, we have seen, there are many technical institutions, which have been set up, right? And they grew exponentially and in isolation. So earlier, the engineering used to be part of the overall comprehensive university system. But of late, there are institutions which are purely technical institutions. I mean, that's what has happened in last 2-3 decades. So if I look at the changes which have taken place in engineering education per se, the engineering education under the title of engineering education did not exist about 100 years back. It happened only in the 20th century when the engineering education as a title got a recognition. Before that, it was only science or applied science maybe, but the engineering tag per se was not there. And there are certain shifts which have taken place in engineering education in last 100 years. First shift has just taken place is from hands-on to the engineering science and analytical emphasis. So before this, the engineering meant that you create something. If it works, you may not have a good comprehensive analytical understanding or physical understanding of that. But as long as the thing worked, I think it was a very good engineering product. In 1935 to 1965, that was the time when people started investigating theoretically how these engineering systems work. And a lot of analytical modeling and things were done at that point of time. The second shift came in engineering education, and that was the outcome-based education and accreditation, which was in 1980s. And of course, NBA model, which is the National Board of Accreditation in India, the Abbott model in US, and many other models which you see across the world, they essentially define the objectives and outcomes for each of the course which students do in their engineering program. So that was the change which took place there. Then the shift on emphasizing engineering design came by the end of 20th century. That it is not only something which works is a good thing, but you have to do proper design and maybe optimal design, energy efficient design, something that would be something of great importance. Then the shift on applying education, learning, and social behavioral sciences and research. Right, that was the shift which has taken place in recent times. And then the shift took place to integrating information, computational, and communication technology in education. And today, when we talk about this, we talk about 3A knowledge society. What that means is information, knowledge is available to anyone, anywhere, anytime, and people access this. Computing power has become extremely cheap. And because of that, the simulation and modeling has really got a powerful part of your engineering program. So few things can be noted then about engineering. Firstly, engineering addresses the contemporary needs. And this point is very important. What that means is that whatever engineering does, it cannot be too much ahead of the time. It cannot be too much behind the time also, because then things will not be recognized by the society. So engineering should address the contemporary issues and contemporary needs of human beings, and that's what engineering does. Second, the engineering depends upon the availability of scientific knowledge at that point of time. So if somebody had developed some gadget, like vacuum tubes were developed in early 20th century, they were the state-of-art technology, because that time the vacuum tube technology was something which was the knowledge which people had in science. After the semiconductors came, the technology changed, the VLSI came, the technology changed. And the engineering essentially kept on using the technology or this knowledge of science which was available at that point of time to best of its ability. And then engineering and society, they adapt to each other. So we should not say that the society keeps demanding from engineering and engineering keeps supplying. Actually, engineering also keep on tweaking itself. And society also keep on adapting to the things which the engineering provides. So this is actually the interdependence which you are having of the engineering and the society. That's how things are. Now, the engineering education with this background of engineering history, one can now ask, what is the engineering education in future? And that is the last point, that the engineering and society, they adapt to each other. What that means is, if you are going to talk about engineering of tomorrow, first recognize what is the society which is going to be tomorrow. Because these are interdependent things. Engineering cannot work in isolation. So understand, unless we understand what the society is going to be in future, near future, far future, we cannot be able to really prepare ourselves, from the engineering point of view. So when we talk about future of engineering education, we should really talk about the society or the world is where it is going to change in future. So the future engineering education will depend upon what the future world will be. As I said, it has to solve the contemporary issues. And what are the contemporary issues in the world that we have to really assess, at this point of time, so that we can steer engineering in that direction. One thing, however, is clear, that the future world will be shaped by the present and the future technology. So this is the interdependency. The society is going to adapt to the technology and the engineering has to change, right, as per the requirement of the society. So essentially, this problem is an entangled problem. Because The engineering and technology depends upon what the society would be at that point of time, and the society at that point of time would be what the engineering is needed at that point of time. So this problem is very complex. A simple example: when the internet came, nobody knew about what the impact. The whole world started getting adapted to the internet technology, and as the things started adapting to the internet technology itself kept on changing as a function of time. So you see now today, when we look at our use of internet, initially it started only from sending emails, then it started sending some voice messages. Now there are videos, and the change which is going to take place continuously, right? Because the world is going to evolve, and the engineering has to really keep pace with that evolution. So now, when we talk about the envisioning of the future, there are two questions one can ask at this point of time. First is, how do we envision the future? Do we have a tool to really envisioning future? And second question one can ask is, what is the objective of envisioning future? Can it be objective only engineering education? Can that be objective? Or can there be a broader objective for envisioning the future? And these are the two questions we have to ask before we address the future engineering education issue. So when we talk about envisioning future, again, you have to ask, what is the objective of this? So is it the objective? Is it an extrapolation exercise when we envision the future? Or is it a path defining exercise? Invariably, you will see when we do the extrapolation or prediction or what we require, most of the time it is extrapolation exercise. Right? But the question we are asking is, what envisioning means? Does it mean simply extrapolation of looking at what we are today? Or should we do the path defining exercise? So if I want to do simple extrapolation of the engineering and technology, the extrapolation always look at what happened in the past and expect the same kind of trends are going to continue in future, and then can make certain predictions in the future. So if I look 80 years back, where the technology or engineering essentially came really in forefront, you see 80 years back, we had things like electricity, trains, cars, aeroplanes, telegraph, telephones, right? Radio, television were coming, and vacuum tube technology was there, and so on. When I look at today, just about 80 years later, we are having new computers, which are just 50 years old. We have internet, which is just 25 years old. We have satellites, just 60 years old, mobile communication, 20 years, and e-commerce, e-medicine, just about 10 years old. So you see, there are a whole lot of engineering and technology got added in last about 20, 30 years. What world, if you ask because of this technology in last 100 years? So there are some landmark engineering and technology which have played an important role in really modifying the world. One, of course, is 100 years back, to go from one country to another country used to take a couple of months. When the aeroplanes came, people could really go within 24 hours from one part of the world to other part of the world. Even within the country, within the continent, people could travel because of the high-speed trains or high-speed automobiles or whatever that. Second thing which transformed the world is the electronics. And we know the impact of electronics, so I don't want to overemphasize that. Right? Today, electronics is practically everywhere, right? Wherever we look at. Third thing which played an important role in transforming the world is the communication and information technology. So earlier, when the communication technology started, it was just for creating a channel for voice communication. But then, as we see, after about 70, 80 years, today, when we are having communication, we are talking about a huge amount of information transfer just by the click of your mouse. That's the kind of expectation we have created. And then biotechnology, as I mentioned, has become part of it. And material science has played an important role, because ultimately, when you try to realize the things in practice, you require proper materials. Right? So material science has really played an important role. With this technology background, if you look at how the world exists today, if I were to extrapolate, you will see today the world simultaneously exists in two spaces. One is the cyberspace. And this space is related to the information, the flow of information. It is also related to the easy access of information, the entertainment. Right? And in this world, essentially only two human senses are active. One sense is the vision, and other sense is the audio. And this cyberspace has expanded so rapidly in last about 20, 30 years. This growth is exponential in nature. Whereas when I look at the other world in which we all live simultaneously, that is the physical world. And in this physical world, what we worry about? We worry about our pleasures, we worry about our comforts of life. We talk about, all the senses we use. So we talk about vision, audio, touch, smell, taste, and whatnot. We also worry about the human relations, love, compassion, happiness, environment, spirituality. These are the things which are in the real world, right? Which we deal with. So when we today ask how the human beings are existing, you will see human beings are simultaneously existing in these two worlds together. And interestingly, sometimes we spend more time in cyberspace than we spend in the physical space. So when I look at the cyberspace, the extrapolation over a long period of time is impossible. At most, right, it could be just the reasonable prediction you can do. But if you want to do a long-term prediction for this extrapolation, cyberspace extrapolation is impossible. And the reason I'm saying this is, if somebody has asked you 10 years back where we would be in 2022, I'm sure all your prediction would have completely gone haywire. None of the prediction would have come correctly because things have completely changed in the last 10 to 15 years. So why this has happened? Because the technology lifespan has become very short. It is just about 4 to 5 years. So you will not be able to tell what kind of technology is going to take to come in next 10 years or something like that. And the social impact of this cyberspace is extremely complicated. Because when we talk about the cyberspace, we talk only about technology, bandwidth, accessibility, and so on. We don't know what are the impacts of that which are going to be there socially. Right? That understanding is still not fully developed. The Moore's law will hit the fundamental limit in next 1 or 2 decades, right? And the question would be what next? So even if I say the electrons is going to continue, in the same trend for about 1 or 2 decades, it is going to reach to the atomic limit, and we don't know what technology is going to come after that. And the complete new technology might emerge at this point. And in cyberspace, the most important aspect of cyberspace is it is location independent. So proximity, when we talk about the proximity in cyberspace, has no meaning, because the person could be across the world and he would be neighbor to you rather than the person who is sitting across the table in front of you. Right? So that kind of thing which may happen in the cyberspace. When I go to the physical space, and just because of this kind of thing, the prediction of this, as I said, extrapolation of cyberspace is impossible. You will not be able to do it. Whereas when I look at the physical space, the extrapolation is linear. And it can be predicted reasonably looking at the past. I can tell precisely, more or less accurately, what is going to happen in future. Take, for example, if I say how the population is going to increase in the next 20 years or 50 years, I can predict the way population is going to increase. I can also predict what kind of urbanization is going to take place and the problems will be caused because of that. I can also predict reasonably accurately what kind of energy requirement would be there in future, the food, water that will be required, looking at the current needs. We can also predict what kind of healthcare will be required and so on. And this physical space is very, very local. It is not global, because all these issues which you are talking about, they are very, very local issues. Right? So one space is the global space, other one is the local space. And these two spaces we live simultaneously. That's the point I made. So in the physical space, when I look at it, where the prediction is possible, right? Cyberspace, as I said, the prediction is impossible beyond about 10 years. In the physical space, if you want to make prediction in future, there are certain predictions which are made by United Nations. So the population is going to increase by about 50% across the world. The energy requirement will go up about 100%. The electricity requirement will go about 300%. The natural resources will be down by about 80 to 90%. The food requirement will go up by 100%. And water stress population will be up by about 200%. If you put all these numbers together, in the years to come, we require the natural resources of equivalent to 4 Earths to sustain our modern lifestyle. Right? The kind of lifestyle which you have created, right, in the advancement. we require the resources which are equivalent to 4 Earths. Okay. So the question then is that this development or thing which we have done in last 100 years just doesn't seem to be sustainable, because we do not have 4 Earths. We have only 1 Earth. And if you have to really make use of only the resources which are available in 1 Earth, or naturally the way we have come in last 100 years certainly may not be the right way of really going ahead. So the passive extrapolation exercise serves no purpose if it is heading toward disaster. And that's what it looks like. But at this point of time, if we do not pay attention to the way we are going, in the years to come, in a couple of decades, certainly we are heading towards a disaster. So when we are talking about the envisioning future, this exercise should be an extrapolation, is possible, the physical but not in cyberspace. So our exercise should be actually a path defining exercise. What that means is that it is not simply prediction of looking at technology and engineering for last 50 years and say what the engineering and technology would be in the next 50 years. That's not enough. We have to say that having developed this understanding of engineering and the development in society, we should now want to define a path, right, for the future. And what is the correct path for development of humanity as a whole? That is something very, very important. So we cannot talk about only specific regions, right, in the world, right, which can flourish, and we can really achieve higher heights. This whole world has to become sustainable. So whole humanity actually has to become a central part. So when we talk about the evolution of the world in 21st century, you may have two scenarios possible. One scenario is the conventional path, the way we have come last 100 years. Let it continue for the future also. And you remain a silent spectator. The technology will keep on doing its job. Engineering will keep on doing its job. Society will keep on adapting, and things will change. Other possibility is knowing that this development which we have done is certainly not sustainable. Create a new transformation, right, for our development, or define a trajectory for your growth. And when I'm talking about growth, the engineering and technology is going to play a major role in this growth of the world in the years to come. So there are two possibilities which are there. So if I go by simply conventional way of doing it, what will happen is there will be continuity of the current patterns, and organic development will keep on happening. So as internet came, it was the organic development. Nobody really planned for it really, that the way it is going to impact society and so on. So technology keeps on coming, organically things kept on happening, and the things evolved. And there is no major transformation is going to be there if you really continue with the status quo. And shaping of the world with socio-economic relationship with industrial society, that's what is going to take place. And the whole world will become the market-driven world. That's what the world today is. Right? We are having a society, we are having the world, which is completely market-driven. Okay. So what the market-driven world does, it has a demographic, economic, environmental, and technological trends which are going to continue without major surprises. As I said, organically things will keep on happening, right? And the world will keep on adjusting to that. The world development adjusts, and the poor regions converge toward the development model of rich regions. That's what has happened actually in last about 50, 60 years. Every part of the world essentially aspires to adapt to the living standards of the rich society. That's what actually it is. And as a result, what will happen is that the disparity between rich and poor regions, right, will grow as the time moves. Right? Because if you do not control it, then of course market-driven will decide where the resources should go, and because of that, only the people who have power and the money, they will keep on sort of taking the resources. And this has created an environmental degradation due to excess usage of resources. We know the carbon footprint problem there. We know the pollution problem there. We know the ozone problem there. All these problems are created because of the very rapid depletion of the natural resources. That's what has taken place. And that has taken place because of this market-driven approach, right, which is there for the society. So if you ask how engineering motivation changed over the years, initially engineering was a necessity-driven thing. When the steam engines came, there was a requirement that we create a transportation, right, which could be faster than what you can do with the bullock carts or with the horse carts. So the engineering was more necessary. In recent time, however, what has happened is the engineering has become more business driven. And what that means is that people are convinced about their some necessities. They probably did not know. You convince them that no, you need this thing. And then you create a business out of that. And then you keep on doing this so that people start getting more and more used to the thing which the engineering and technology is going to provide them. So as a human development, if you look at it as a whole, actually has got a backseat in this. Because the model has become more business-centric model, right? It has become just development means the money, and the human development as a whole actually is not certainly a prime focus. However, what we need when we talk about the development, what do we really need? We need that our well-being should be taken care of. What that means is there should be prosperity, there should be happiness, there should be health also. And the time effluent should be as low as possible. Today in society is happening something opposite. People are too busy in doing all kinds of things. So you see, look at the successful people, right? They are too busy in their business or where they are getting success, and they are compromising on their happiness. They are compromising on their health. So as a society, when you look at, the trend should be exactly opposite. The well-being index should be going up, and the time effluent should be actually going down. Second thing which we want is in the world is we want social cohesion, and we want less disparity in the society. It is what is happening because of technology. Technology again is happening exactly opposite. People are now getting more and more cohesive. Actually, people are getting more and more isolated. Take a simple example, just because of the internet technology. Today, people within a family don't talk to each other much, but they keep on talking to people who are somewhere whom we don't even know, right? Who are your the Facebook friends or something, right? So the social cohesion, which should be a priority for any sustainable world, that is certainly getting compromised, and the disparity in the society also is increasing. So there is a coefficient, what is called a Gini coefficient, right? That ideally should go down, so that disparity in society should reduce, right? And our development should be in that direction. We also should be worrying about the environment. That means the climate, the CO2, the carbon footprint, that actually should be going down. Today, actually, it is going up. Some corrective measures have started taking place, but at this point of time, we are really compromising on the climate. And the ecosystem and the protected land, right? That is something should be our priority. So we are doing deforestation, we are doing lots of chemical wastage deposited on the ground. And because of that, actually the land quality is becoming worse and worse. Right? So when we are talking today about the development, right, and the engineering which we are doing for the improvement or for the human society, in fact, we are doing something which should be going in opposite direction. So we should be more focusing on well-being. We should be more focusing on the community. We should be more focusing on the environment. Right? We should not be using about technology which can be used very easily for the terrorism. Right? We should be using technology for the peaceful activities more. Right? That's what we need in the society. That's what we want our engineering and technology should do. So we want when we talk about today the path defining exercise, we certainly have to do the new transformation. We cannot be satisfied with the status quo. We cannot say just be a silent spectator and let the things happen the way they have been happening, right? In the last 50, 60, 100 years. So the world responds to the contemporary challenges, keeping humanity as a whole in mind. And let me again remind you that when we talk about humanity, we should not be talking about only a limited section of our world's population. We should be talking about humanity as a whole. Right? And prioritizing environmental sustainability and adjusting values and behaviors so that we attain the sustainability. That should also become part of your development process, right? Which is engineering and technology dominated process. So we require eco-communalism, And we require actually a new paradigm, right, for our development, for our engineering path. So some important observations when we talk about the future world, right, and defining, creating engineering education, we can make some observations at this point of time, right, that is regarding the future world. First, the future world will be technology dominated, right? Whether we want it or we don't want it, technology is going to become a very strong integral part of our day-to-day life. And we have seen from COVID-19 pandemic that technology has really played an important role in last 2 years. Imagine if the technology was not there, if the engineering was not there, then we would have completely become standstill. Our entire system, the world would have collapsed. But thanks to the internet technology, thanks to communication technology, the things kept on happening. The world did not really collapse. So technology has played a role, and it has showed in importance in that is going to play in the years to come. Technology is going to be unpredictable, and its lifespan will be shorter and shorter. So about 100 years back, what happened in 100 years? The same thing happened in engineering and technology in last 10 to 15 years. And if the same thing happens, maybe what happens in last 20 years is going to happen in the next 5 years, right, in this domain. And third thing, the future world will be interconnected. So the ICT is going to dominate in the entire world. And the future world will be global and the local at the same time because of the technology which is going to be there. And then the future world will be stressed for natural resources. So when we are going to create tomorrow's engineers, they should be aware of these things. They should be knowing that technology is now going to be a part of the day-to-day life. The lifespan is going to be shorter. ICT is going to play a role. We have to deal with cyber and physical at the same time. And we have to deal with the stressed natural resources, right, when we talk about development of society. So with this understanding, then one can ask, how should the world advance? And it will be immediately clear to us that it has to be holistic and not only engineering. What that means is that the steps which people have taken in between, that engineering started working in isolation. That may not be a correct way of really handling engineering in future, because we require a holistic development, understanding, of the society, so that engineering becomes more effective. Engineering is problem solving, and that is basically the strength of engineers. You give them any problem, they will solve it. They will give a solution to the problem. Right? Question is, who will pose the problem? Engineers cannot pose the problem because the problems are not always related or lying in the domain of engineering and technology. The problems are lying somewhere else. The problems are lying in the social domain. So engineers can solve the problem, but the correct problem needs to be defined. And that has to be done only which will define proper human needs. So if I go by Mahatma Gandhi's statement, there is enough for everybody's needs, but not for anybody's greeds. And today, that's what is happening. That a lot of resources are getting cornered by very few people in the world, and that is happening, right? Which is there. So what that means is, when you are doing the engineering development, the engineer should also understand how the human needs are going to change, and can we really tame them? We should not leave them free. And social scientists should become an integral part of engineering development. So engineering cannot work in isolation. They cannot really say that, well, I will develop technology and I don't know who is going to make use of it. They should see what is going to be the impact of this technology, this engineering, and how the world is going to change. And ultimately, this whole development has to create a happy society. That's what should be the objective, for the world in the years to come. So the equitable distribution of resources and human comfort. Now, this equitable distribution is very, very important. And why I emphasize that is that about 100 years back, there were the regions in the world. Some regions were very rich, some regions were not that rich, some regions had all kinds of facilities, some regions were completely deprived of even the basic facilities. But the thing survived. Why it survived? Because these two worlds did not communicate too much. There was no medium to communicate. So if you go to some poor country and you tell them there is a very affluent country somewhere there, right? You could probably imagine that what kind of affluence would be. But you never go there. You never really go and physically see what kind of difference is there between the two worlds. What this internet technology has done is it has made everybody aware of everybody's privileges and everybody's limitations and shortcomings. So because of that now, when we say that now there's going to be too much of disparity in the society and not equitable distribution of resources, this is going to create an unstable society. It's going to create an unstable world. Right? So a development of the world, when we saw in advance, when we move, we should do development which is sustainable and in harmony with ecology, and it will be having equitable distribution across the world. Right? So going to the motto of IEEE, I think our technology and engineering should be advancing technology for humanity. And that should really become the motto of engineering and technology, that we are advancing for the humanity as a whole, and not only the development for the business or those kind of things. So there are a few technologies which are already in pipeline, and you will not be able to do much about them because they are really either at the advanced stage or they have got an inertia which is going to drag you for at least next 1 or 2 decades. So the artificial intelligence, the Internet of Things, wearable electronics, right, cloud computing, virtual reality, augmented reality, all these technologies are 25 technologies which have been predicted, which are going to be there, right? Which are going to play a very important role in next about 1 or 2 decades, right? So we will not be able to do much about that. In future, if I go beyond that, there could be some engineering which are going to come. You could have bio-inspired engineering, right? Which people foresee there is going to play a role. Marrying biology with information science, that is going to be a trend which will be there. Artificial senses will be created, right? You require everything which the humans are doing can be done by the machines, which can be done much more efficiently. So you'll require artificial senses. Self-organizing system and self-healing systems, which would be something, one of the challenges which people will be working right in the years to come. And the non-silicon based system probably would be the future, right? Because so far we have done only silicon, but maybe the carbon based system might really start playing a role, right, in the coming century. New materials, reconfigurable materials will be developed. Complete renewable energy system, which will be sustainable, that will be the priority in the future. And cost-effective desalination of water, because the whole civilization is going to be water stressed. So we require a cost-effective and desalination of water, right, in the years to come. So with this development of, then we can ask, what will be the future education? How do we really steer it? So the essential of future engineering education, first thing we have to do is we will require de-compartmentalization of engineering. We cannot identify ourselves only with one discipline, because most of the problem which we'll be solving, those problems will always lie at the intersection of multiple disciplines. So engineer cannot say that I'm a computer engineer, I'm an electronics engineer, I'm a telecom engineer. He has to just get a broader understanding, right? And these borders which you have created in last 50, 60 years in engineering disciplines, those borders have to become weaker and weaker. And there should be a diffuse movement of the engineers across these boundaries, right? Even at the education level. Technology-enabled lifelong learning and self-learning is going to be a norm. Because as I said, technology lifespan is going to be only about a couple of years. That means what you study in your engineering program, that may not be adequate. You have to keep updating yourself. Things are going to change. So self-learning and lifelong learning will be the norm in the years to come. Interdisciplinary and system-based approach, that is going to play a role. And sustainability really will come in the front. So we will be talking all the time about green engineering. And what that means is when the engineers talk about the product development, they have to talk about the product development and its life cycle functioning, right? So that over the time of its life, it should be sustainable. It should not be damaging the environment, right? And it should be ecologically, it should be correct, and so on and so on. And liberal art to get more integrated in engineering education. Because as I said, if you have to really change your needs, the need change has to come from the knowledge of non-technological courses. The liberal art has to become an integral part of engineering education. So you cannot say in future that engineering is going to work in isolation. You cannot have institutions which are purely engineering institutions. We have to have a good integration of the engineering and the liberal art program, and higher involvement of in public policy due to more integration of technology in our life. So far what was happening? The engineers were actually isolated. They were never involved into too much into the public policy or even politics and so on and so on. But as the technology is going to play an important role in your day-to-day life, and without that, your day-to-day survival will not be possible. You have to now devise policies which are really policies which understand the development of technology and engineering. And that's why the engineers should become policy makers. They cannot now remain spectators, right? Politicians or the other people cannot really decide. Engineers should start playing a very important role in defining what the policy would be for the development and evolution. So what that means is that in summary, it is not only the engineering, but what we require is a new education system for future. And engineering could be only just one part of it, but we require a completely new education system. Or is there the education system which was ancient education system, which took all this sustainability, the ecology and everything into consideration? So when we talk about a new education system, should we really look back again our ancient education system and say how did people survive there for last 1,000 years? And if that was the right approach, maybe that has to be integrated into the new education policy which we are talking about. So of knowledge, skill, value system, sustainability, happiness, that should become really be integrated or inculcated in the engineering students. Preservation of culture, geographical, biological, and natural diversity, that should be imparted to the students. We should say that we want diversity in this world. We want cultural differences in this world. We should not be homogenizing the entire world. And that thing has to be inculcated from the young days, when you are at the student stage. Living in collaboration and cooperation with nature, that should become really as the way of life, right? Rather than saying that I want to keep on conquering the nature, right, and keep on using resources beyond the capacity which the nature can provide. So the correcting the path traveled over the last 50 years, we have to correct this path over the next 50 years so that we reach to the sustainable one. So what that means is that, to conclude, right, the engineering is certainly going to play a very, very important role, but engineering along with other education system total, we need to create a new value system. So engineers and social scientists together have to create a new value system and paradigm of growth. The business-centric approach, the luxury-centric approach cannot really take us very far. So we require a new value system we need to create. But creation of a value system is a very, very slow process. You cannot change the value system of somebody overnight. You require one generation. In fact, even one generation also imparts the value system to the next generation. So if you wanted to have a complete transformation into your value system, last 2-3 generations, whatever the changes which have taken place, now systematically, we have to keep on doing some changes in the value system for coming 1 or 2 generations, so that when the 3rd generation comes, it will be really comfortable and conversant with the value system which we want, which makes the entire world a sustainable one. So education system have to impart correct values to next 2 generations to have the right beginning of the 22nd century. So if we really plan our development, and if we take our engineering and science approach in such a way that our target is when we reach to the 22nd century, that time we will be having the entire world, which will be having a reasonably good equitable distribution of natural resources. The society will be reasonably happy, right, and comfortable, right, and it will be sustainable society. So beyond that century, then with that way of life, the perpetual sustainability of the society can really exist. And that's what actually the engineers have to do together right, with the social scientists, right, and the other education system. So thank you very much for this opportunity for giving this thing in this talk. If you have any questions, I'll be very happy to answer those questions. Thank you very much.
Thank you, Professor, for your interesting talk and your interesting ideas. So what we can do now, we have a chat, which you can find at the base of your screen. If you can type in your questions there, and then we will ask Professor questions. Also, if you would like to give us feedback, there is a link to a form. If you can fill it out, it will probably take 1 minute so that we will see how you feel about these presentations and the seminars. So yes, if you have any questions, please make sure to put them in the chat. And I would like to ask first question, if you don't mind. So you have very interesting series, or maybe about changes in the world, right? So that would be different from like what we see now. There is a large change in the cyberspace and in the physical space. So do you think we will have to, we actually need to teach our engineering students differently, because we actually know there will be changes in the world, and these changes will be very rapid changes? So this is my first question. And my second question, you also were saying that we should teach them different things, like not only one discipline, right? So it should be a multi-discipline. So in this case, if we teach here at Griffith for 4 years, like one discipline, if we teach them like another one, it will probably take like another 4 years. So altogether it might take like more than like 6-7 years. Do you think that's a good way to look at this thing? So what do you think about this?
Yeah. So first thing, of course, that engineers have to be made more aware of really the societal issues, which at this point of time, I don't think engineers are really trained. That is one thing. Second thing, when we talk about interdisciplinary thing, we have to very judicially ask a question: what is the core or what is the minimal thing which the student should know, which requires really a guidance from somebody? Beyond that, can they really develop something on their own? And you will see, if you do this exercise very, very critically, you will see the logical reasoning development of the student rather than the content. That is something very, very important. Today, when we talk about engineering, the logical development has a small fraction of it. Beyond that, it is repetition of the same thing applied in different scenarios. That's what most of the time happens. I'll give a simple example in electrical engineering. Right? When we talk about, let us say, digital signal processing kind of application, right? The fundamental understanding is simply just the transforms and the transfer function of a system. If you understand that correctly, right, you will be able to apply to a variety of applications which are there. And that showing from different disciplines the same concept, how it can be used, and leaving the student to really explore the possibility of seeing those things. That would be one of the better approaches, right? Which even earlier people used to follow that. Only over the years we have made them more compartmentalized, to say that electrical engineering should think more about electrical engineering. So this change has to take place, because the problem which you are going to face, they are going to be always multidisciplinary, and they will never be straight-jacketed into one of the disciplines. Right? So that's what I would feel.
Okay, thanks. I'm looking through the chat, and there is comment from Hans saying that maybe it would be nice to bring it to one of the conferences, A Square. So here in Australia, we have annual, probably one of the biggest educational conference in engineering, so A Square. So and then Engineers of Australia is one of the accreditation bodies that engages so actively and consistently with engineering education. So this is kind of like, this is actually like very interesting topic also in Australia. So something that we're looking at, and that may be like one of the things like to discuss it at bigger table at a bigger conference, square, and see what we can do here in a study, how we can look in the future, predict it, and then adjust our educational system to cater to those changes in the future. Okay, thanks.
Good idea. Yeah, I'll be very
Yeah.
happy. Yeah, we
And
should discuss it.
Yeah, I think maybe we should discuss it at even like a bigger conference. So, and then I have a question from Sripad. When you say we have moved towards outcome-based education, right? So people might ask what earlier the education didn't have any outcome. So like if you talk about like what we're going to do in the future, like outcome-based education compared to previous, so was there any also outcome-based education?
Yeah.
Can you please comment on this if possible?
So when we talk about this new outcome-based education, so when we look at, for example, accreditation, and when you define outcome, I know very clearly, which come from ABET, that after doing this particular course, what the students will be able to do. That's what the outcome actually has to spell out. I remember there were many courses when I was a graduate student, or even earlier than that. You used to do those courses, right? Not because you will be able to do something, but something for your intellectual curiosity, which could broaden your thinking capability, your reasoning power, your rationality. Even those courses used to be very, very important courses. Now, every course, if you ask how this course is going to help you to do something, where the outcome-based education wants you to define, many of the courses probably will not fit into this structure at all. So today, when we talk about education, it simply says the engineer will be able to do this after doing particular content. Earlier, this was not that clearly defined. So if you do a course on cosmology, you ask something, what you will be able to do after that, your answer would be nothing. Right? But still, understanding cosmology widens my thinking capability. Right? I can understand the world or the cosmos much differently. I can understand the physics much differently. So it had a value in developing my logically reasoning power. Right? Today, the outcome-based system probably doesn't really emphasize too much on that. Just for enjoyment of something, which would you like to do? Probably it is not really part of the outcome-based system. Right? That's what something is happening in engineering. And I think the philosophical aspect of education also is equally important. Then what are the deliverable aspects of education? Engineering talks today about the deliverability, but philosophical aspect probably is not really that much rooted, right, into the new approach, which is the outcome-based.
Well, thanks. There is a comment from Arvind saying that I like the idea of separating the world in cyber and physical space. When you talk about changes in cyber, which we cannot predict, and changes in the physical world that we can fairly well predict. Okay, are there any more questions? I just have sort of I don't know, a question, a comment. So you talked about like changes in the world, like cyberspace, online learning, right? And then you were saying that it's not really good when students spend like so much time in social media like Facebook. So I think we should have some kind of a balance. So people should like still like talk to each other face to face, right? But also we should use all these advantages from the current technology when we can do remote teaching, and we can also benefit from that. So this is like very probably like difficult things to do because like the way that like we learn, it was like face to face. We didn't have internet, we didn't have iPhones, and now like if you look at like kids now, like they don't even talk to each other face to face. They just like chat. They like send like messages. So they sort of lost that way of communicating them like that we used to have. So when we look at them and say, well, this is wrong because you should talk to each other face to face, but then they like it's changed. We cannot really change them. We cannot just force them to like stop using the current technology, even social media. But Well, what I'm thinking, we need to find that a balance between like face-to-face interaction and at the same time, like use all the technologies. So what do you think about that?
So I would say, that we should look at technology should be assisting what the humans require. Technology should not dictate to the humans what they should do. What has happened in last about 2 decades, technology has started dictating the humans what they should be doing. I'll give a simple example. The pandemic or non-pandemic, the online teaching methodology came in existence when the ICT became available. Now what we are saying is, you change your teaching methodology, which suits this technology. I find a lot of limitations in that. Today we are saying you conduct your examination in such a way which will suit this technology. But that's not the best way. I want to test the understanding of somebody. But I have to do it because the technology is saying, no, only this is the way you can do it. So what my point I'm making is, technology should be the slaves of the humans. Humans should not become slave of technology. And that thinking has to be always kept behind your back of your mind, that no matter where we go, we are the people who should be telling what we want, and technology should provide that. Rather than technology should be saying, do this, right? And you start doing it. So I have seen, for example, teaching methodology which has taken is completely disturbed. Maybe the physical mode may not be the best mode, because it has certain limitations. But have we got today now in the pandemic? Today now people started thinking this is going to be the norm in the world. The entire education system is going to be online. We are going to create online universities, right? So question we should ask is, in this entire analysis, have you ever asked the students what was their experience in this online teaching? Students were never become part of this. Only experts are commenting on and discussing these issues. If you ask students, no student really want to learn and give examination in online mode. He really wants to come and interact with his peers, with the professors, and with other people. So what is happening is slowly that we are sort of adapting ourselves to what is available, rather than saying that no, I want this, and let us work towards it. That's the approach probably we have to develop in the years to come. That's what I would say.
Well, thanks a lot. Just comment from Hugo. If you would like to give us feedback, please fill out this form. There is a link in the chat. Are there any more questions? Because it's already 3 p.m. and I would like to conclude the seminar. Any last minute question? Well, if no question, thank you, Professor, for your time, for your interesting presentation, for sharing your ideas with us. It was really interesting, useful, and see like what you're doing in India, and then we're actually like trying to do like same thing in Australia. So that's a very good way of sharing knowledge and experience. Thanks a lot, and everybody, thanks for attending this webinar. Please attend our next webinars, which will be next month. So I will do it on a monthly basis. I will send you emails, and Professor Selvan will also send you email about our future seminars. If you actually are interested in presenting at one of our upcoming seminars, please let us know, and we'll be happy to discuss it with you. Thank you, everybody, and have a nice day.
Thank you so much. Thanks for inviting me. I'm delighted to be here.
Yeah,
thank you
thanks.
So much.
Thanks, everybody, and bye.